We are now going to go into section 6 where we are going to subtract fractions. So to subtract, it is very similar, in fact, to adding. And I'm going to start out with a little example here off to the side. Imagine you have 5 minus 2. Not a very hard problem, but I just want to make the point that it is conceptually exactly the same to 5 plus a negative 2. So if you see something like 5 minus 2, you could change it into 5 plus negative 2 and get the exact same answer of 3. Another quick example off to the side here. If we did 5 minus 2 minus x. Now this gets a little bit more complicated because if we want to change this into an addition problem, we are really going to need to make it plus negative 1 times all of that stuff. And so if we were to distribute this out, we would get 5 plus negative 2, which is exactly what we would expect, that negative 2 apply to that 2. But it would also change the sign of the thing over here. So if we take negative 1 times negative x, it would become positive. So it flips the sign, changes the sign of everything in the parentheses, or when we get to fractions, everything in the second fraction in the numerator. In this first example of a subtraction problem, you'll notice that we have common denominators. So when we do this problem, we're going to skip a few steps in our flowchart when we get to the adding step, but I want to pay especially close attention to the things we do in the subtraction part. If we start with our flowchart here, we are going to go through the start and do our parentheses around the entire numerator and the entire denominator. And we are going to decide which operation we're working with, and that is subtraction. So if we start, get our parentheses, and then we're going to head over here to subtraction, where we are going to change the operation to addition and multiply the numerator of the second fraction by negative 1. Only the numerator, only the second fraction. So let's do this one step at a time. It says put parentheses around everything. So parentheses around everything, just to be safe, making sure we don't goof up order of operations. Then it says turn the problem into an addition problem. Boom, we just turned that subtraction into addition. And multiply the numerator, so the top here, of only the second fraction by negative 1. Just like that, we turned subtraction into addition. We took parentheses around it all, we changed it from a minus sign to a plus sign, we multiplied the second fraction by negative 1. And now, let's continue with our chart. It says first, simplify each fraction separately. Let's just see if anything reduces here. If we look at our groups, we have this whole big group here and then just an 8x squared on bottom. There is nothing in common with everything, and the two groups themselves are completely different looking, so that's not going to work. Over here, same idea, nothing in common all the way around, no way that we're going to be able to factor something out and cancel from top to bottom. So looks like simplifying the fraction is not going to work. Next, it says that we need to choose a common denominator. Well, we already have one, it's 8x squared. So let's continue on. Multiply a numerator and denominator of one fraction by the same factor to get the common denominator. Well, we already have a common denominator. Let's move on. Distribute across the numerators to remove parentheses. So now we want to get rid of our parentheses up on top. Up on this first fraction, we have nothing going on up there. We have no number out front. We have no exponent up here. We can clear those parentheses already. So let's go ahead and do that. They're gone. Over here we do have something out front. We have a negative 1 out front, and we need to distribute that then to everything inside this fraction. So that's going to be 2x becoming negative 2x. That's going to be negative 3y becoming plus 3y, positive 3y. And when we do all of that cross this out. I'm going to move this back over here so it's a little easier to read. That is now our problem. We have a common denominator. Our tops have no parentheses on it. So let's see what we can do with that. It says now add the numerators in a single fraction over a common denominator. So add the numerators in a single fraction over the common denominator. That means we're going to combine what we have up on top. 5x minus 5y minus 2x plus 3y. We add straight across since it's an addition problem. All over 8x squared. Slide that down here so that we have a little bit more room to work and clean things up. Next step says we need to combine like terms in the numerator and then go ahead into the simplify process. So if we combine our like terms up here, we have x's and x's. We have y's and y's. So let's do that. So 5x and negative 2x is going to be positive 3x. Negative 5y and positive 3y. Negative 5 and positive 3 is going to make negative 2y. So we are left with this on top. And then we go into our process of simplifying. So that's our numerator. To simplify, it says factor all groups fully. Let's start out by factoring all groups fully on top and bottom. Well, on top 3x, 3 and 2 have nothing in common, x and y have nothing in common. We actually cannot factor anything out of that. We could maybe factor a 1, which is not helpful. And so if we fully factor that and look at the fact that nothing's coming out, then we don't even need to bother breaking up the bottom. We could break up the bottom to 8 times x, but again, not going to do us any good if we don't have anything on top to cancel out with. So we are going to be at the end of this problem. Since we're not going to focus on excluded values in the addition subtraction problems, we can skip that step for now. And it says eliminate common factors. Well, we don't have any common factors. So we are done. So this is our answer. If you wanted to write it a little bit nicer, then hope that you have digital paper like me so that you can just do that. Oh, and do that. All right, moving on to the next one. We have x plus 5 over 2x plus 2 minus 2x over 2. There's a few opportunities we can have to make this problem a little bit simpler right from the beginning. Let's work our way through our flowchart. First step, as always, get parentheses on it and then determine our operation, which is going to take us to subtraction. So first step, parentheses everywhere. The reason we do that is so that we don't forget steps later. Now in subtraction it says change the operation to addition and multiply the numerator of the second fraction by -1. So let's change this to an addition problem and multiply the entire numerator of the second fraction by -1. There we go. Done. Then we go to adding. So it says first simplify each fraction separately. So if we look at these two fractions, the top and bottom groups on the left here do not appear to have be the same. They look fairly different. On the right though, I see a 2x over 2. And so if I call this 2 times x, you can really, because it's multiplication, split it up into a single group like that. If you have no addition or subtraction signs in a single group, you can actually split every single thing inside of it into its own little mini group. Over here, I could not do something like this, not do that. And the reason for that is because this group has a plus sign or a minus sign, you cannot go splitting it up like that. What I can do is when I have a group with no subtraction, no addition inside of it, that I can split up, and I can even take the numbers and divide it down into single factors. So if I do that, in this single fraction I have a group of 2 and a group of 2 on top and bottom that can in fact cancel out with one another, leaving me with just x over no fraction, which means over 1. So that can be handy. In this particular problem, it actually wasn't going to do a whole lot for us, to be totally honest, but it does simplify in some cases the process. So continuing on, it says choose a common denominator. When we look at these two fractions, this one has 2x plus 2 in the denominator, and this one has nothing, or 1, in the denominator. And so choosing a common denominator is actually going to be pretty straightforward here, and the reason is we're just going to use the 1 on the left as our common denominator. So we're going to multiply the top and bottom of this by 2x plus 2. So top and bottom of this right side fraction by 2x plus 2. Let's check our steps now. Multiply numerator and denominator of one fraction by the same factor to get the common denominator, and repeat on the second fraction. Since we already have it over here, we don't need to do anything additional. Here we multiply top and bottom so that we have the common denominator. So we did that, and we are moving on to distribute across the numerators to remove parentheses. Distribute across only the numerators to remove parentheses. So over on the left side we have nothing out front and nothing as an exponent, so we can just get rid of those parentheses right away. On the right side we have something a little bit complicated. I'm going to write it out off to the side just so we can kind of see why this is a little bit messy. We have negative 1 times x times 2x plus 2. That's what we have up in this numerator here. We have 3 chunks times each other. And when that happens, it's almost as if you were doing something like 2 times 3 times 3. You have the option to do the first 2 first and then multiply by the second one after that. So if I were doing this problem, I might do 2 times 3 is 6, and then 6 times 3 is 18. So I would do this in 2 steps. And in the same way, we're going to do this one in a couple steps. So I have a negative 1 times an x out front, and I'm going to get negative x, or negative 1x, times 2x plus 2. So I combine these into a single chunk right here. The benefit to that is now when I distribute, I can take one thing times both of these. So negative x times 2x, I'll make this a negative 1x just to make it clear what we're doing. Negative 1 times 2 is negative 2. X times x is x to the second power. So negative x times 2x, negative 2x squared. Negative x times 2 would be negative 2x to the single power, to the 1 power. So this numerator over here became negative 2x squared minus 2x. And we've replaced all of this mess right here. So now we want to go to our next step, which is to get it into a single fraction. So add the numerators in a single fraction over the common denominator. So let's get this into a single fraction. To do that, we write it all over. 1 common denominator, 2x plus 2. And then we have our x plus 5 minus 2x squared minus 2x, all up on top. Finally, it says combine our like terms before jumping into simplifying. So we're going to combine our like terms and then simplify. Like terms in this case is things to the only multiple terms would be these. The rest of those are unlike each other. So we have a negative 2x, and this is a positive 1x. And when you combine positive 1 and negative 2, add them together, you get negative 1x. So we'll write negative 1x out there and get rid of these two. And typically when you have multiple powers of x, so x squared is x and then constants in the same problem, we'll write them in order of their power. So negative 2x squared minus 1x plus 5 is all over our common denominator of 2x plus 2. So we are going to go with the more cleaned up version written in that order. It makes it easier to do things like factor later on. And then we go to our simplify step. And in our simplify step it says factor all groups fully, and then eventually we'll eliminate common factors. Factor all groups fully. This right here has nothing in common all the way across, and although it is an x squared term, we have not talked about or looked into ways that you would factor things that have a number in front of the x squared like that. So even if this were possible to factor, it's not something that you would have practice or have skills with right now. So we are going to leave that as is. In the denominator, you notice that both of them have a 2 in there, and you could write this as 2 parentheses x plus 1. Take that common 2 out of there and leave your answer looking like this. Now, because we knew the top wasn't going to factor, we could have just said, what's the point of factoring the bottom? Nothing's going to cross out regardless. So you could have left it 2x plus 2. Either would have been acceptable in this case. So you have this or this as a denominator in this problem. That would have been okay, but your numerator should look like this.